Alrighty, here we go. This is the second half of your inverse note. This one's on exponentials and logarithmic functions. And that is because they are inverses of each other, but we will get to that shortly. I have 5 grids in all set up for these 5 questions. I hope to finish them all before I fall fast asleep. So I'm going to move each one to its very own grid. So we can do this kind of like the lesson that I did to remind you what inverses were from grade 11. I'm having a little trouble here. I don't know that the grids are properly placed. Honestly, I just made one grid and then cloned it, so don't trust that everything should be perfectly centered. All right, so let's go over what the graph of y equals 3 to the x looks like. And know that this generally is considered an exponential function, and that 3 could change. So generally it's called y equals a to the x. Quite possibly in grade 11 you use this as a 2. So I'm using it as a 3 right now. It really doesn't matter. The process is the same. So this question is asking us to graph each of the following. So those are the 5 that I had originally there. And you can rewind if you really need to see all of them at the same time. So I'm going to make a table of values. Now there's no transformations with this one, so we're not moving it left or right or flipping it or stretching it or compressing it or any of that kind of stuff. So I'm just going to make a little table of values, totally rough. And this table of values is the one that I will eventually flip so that we can graph the inverse. So just to go back, because I saved this note, just to go back, that when we graph the inverse, we graph the original, find a few coordinates. So I'm doing that right now. So I'm kind of doing these backwards. Switch the x's and y values and graph the new set of points and call that the inverse. So we're going to pull that off with this picture, which may or may not be familiar to you. So I'm going to put 0 here, because 0 is an x value I want to use. And I'm going to use 1 and 2 and 3. And if I need to, I can fit 4 down there. And I'm going to pick -1 and -2. I'm going to start with 0. So you should know that 3 to the 0 is 1. And 3 to the 1 is 3. And 3 to the 2 is 9. And 3 to the 3 is 27. So I'm not going to do 3 to the 4 because I'm not even going to reach 27. Checking that this is on. Yes, it is. Then 3 to the -1. That will be 1/3. So a reminder that 3 to the 1 is 3, and then the negative flips it or does its reciprocal. 3 to the -2 will be the same as 9, but it's reciprocal. So you can see why I may not do any more of these, and we'll just go with what we've got here. So y on the y-axis, x on the x-axis. I think this one's perfectly placed. I'm just going to put these dots on the curve as well as I possibly can in red. So 0, 1 was the first one I started with. 1, 1, 2, 3. I think I can fit in 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, barely. Then -1, 1/3, we're going to have to fake it a little bit. And -2, 1/9 will be a little bit closer than 1/3, so this is going to be tough. And I hope you remember from grade 11 that this particular curve, as in the exponential, the J curve as I choose to call it, actually has a horizontal asymptote when it's not transformed in any way. The horizontal asymptote is sitting right on the x-axis. So I'm going to put it there just so you can see it. That will have a label of y equals 0. Everything gets labeled when you put it on there. That means as I start to input larger negative values, so -3, -4, -5, this curve is getting closer and closer to the x-axis, but it's never ever touching it. So I am going to join these in a smooth, I hope, curve. Okay, I've already botched it, but we'll deal with it. And what matters is that you don't do that. Okay, none of that. You can't come back up. You have to get closer and closer and closer to it until you think you're going to touch it. And then when you think your curve is going to touch it, you put the arrow on. So I didn't do a very good job, but as long as it's not, as long as it doesn't look like you did it on purpose. So this is f at x is equal to 3 to the x. For the record, if that was a 5, this would get bigger faster. If it was a 10, even bigger faster. So it would come in here and it would cut down because it would get smaller faster. If it was a 2, it would be down here a little bit, so it would get bigger just a little bit slower. So this is representative of a lot of things. Hopefully, if you are getting 300% interest, which you will never do, this is a picture of how your money grows from 0, so this part doesn't exist. So this would be a picture of what your money does. And I think I promised to myself to mention that this is how the COVID curve is actually supposed to work as long as you have exponential growth, which of course we don't want, but that's what everybody was talking about with the curve. You don't want this shape because that means the population is getting sicker and sicker, quicker and quicker. So you want to keep this number at its minimum when you're talking about pandemics and things like that. So let's do the old flippy thing. Enough of that COVID talk. So I'm just going to make a little list here. And I'm going to flip them. So 1/9, -2, and 1/3, -1, and 1, 0. I should be putting brackets around these because they're not in chart form this time. 1, 3 turns into 3, 1, 9, then 2, and there's no way I'm putting 27 on there, so I'm not even going to go there. So I'm going to do the ones I like first. So 1, 0 is here, and 3, 1 is here, 4, 5, 6, 7, 8, 9, 2 is there. 1/3, I'm going to have to fake that a little bit, down 1, and in a little bit closer. So, like I said, joining them. And with this one, as soon as you think your pencil is going to hit, you throw in the arrow. So I don't care if the arrowhead hits the asymptote. And I hope you realize that there is an asymptote, only it is reflected. So now your asymptote is here for the blue one. So that is a vertical asymptote with a label of x equals 0. All right, so that's the picture. And I am going to label it f inverse at x. All right, so I know that when we did yesterday, or the last note, the inverse part 1 note, that I started to do the equation at this point. I'm going to come back and do the equation in a minute. The first thing I want to do before we do the equation is at least one more of the graphs. So I'm going to take this here, and I do want you to know that there is an absolute relationship between question A and question B. Question A used 3 as the base, and question B uses 1/3 as the base. Now what that means, and I hope you can understand this because maybe your grade 11 teacher went over it, don't know how long to make that, is when I create my list, 1/3 to the 0 is 1, 1/3 to the 1 is 1/3, 1/3 squared means I square 1 and I square 3 and I get 9. And I hope you realize that this is kind of the backwards of the one where I used a very similar base, but the reciprocal of the base. So when I go to do -1, that's going to be the flip of this. or the flip of this base, which is 3. And when I do -2, it's the flip of this base but squared, so 9. And I'm going to plot those points on this curve. I'm just going to move this over because to my eye, I don't think it looks very nice. So we have dots, -2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I don't have enough space. I have magic smartboard abilities. Sorry for those of you who don't. You have a magic eraser. So -1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, 1, 2, 3, 0, 1, 1, 1/3, 2, a little bit closer. So you have to fake that, which is why we call this sketching and not graphing. I am graphing dots as well as I can, but technically I'm sketching down in this area because I'm doing no actual measurement. So what I hope you see, is that this picture, oh my gosh, which is f at x equals the reciprocal of 3 to the x, so 1/3 to the x. This picture, if I had a pretty picture, and this red picture are flips over the y-axis. And that's not an accident because a reciprocal is actually a flip, and it means that there was a -1 hanging around somewhere. So this is not unexpected. The difference between this picture, which has a number here that is greater than 1, and this picture, which has a base that is less than 1 but still positive, is that this picture in red represents growth. So if you get into the positive x values, this is growing and growing and growing and growing and growing. And this picture represents, after you get into the positive x values, decay. So when we get into word problems that talk about exponential growth and decay, that's the picture that matches the information. So now I'm going to do the inverse, where my steps don't change. So 9, -2, 3, -1, 1, 0, 1/3, 1, 1/9, 2. And I'm going to do my best job, hopefully better than red. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yay. -2. 1, 2, 3, -1. 1, 0. 1/3, 1. See, I'm sleepy. And that one tucks in a little bit tinier. Okay, wish me luck here. Not bad. And again, that's the inverse. And for both of these graphs, just like all of the other one, if you tilt your head sideways so that your right ear is touching your right shoulder and you look at this on a 45-degree angle, or you put down the line y equals x, you will see that the red and the blue reflect onto each other. Also know that I'm not going to put it down because it looks like there is one already. There is a horizontal asymptote for the original running through the x-axis, and there is a vertical asymptote running through the y-axis for the inverse. So just like this guy. All right, I'm still not going to do finding the equation of the inverse yet. I want to do one more graph, so I keep lying to you. Sorry about that. And this time, I've messed with the y equals 2 to the x graph because I've added on a 2. So some of you may, and I warn you a little bit, some of you may want to restart a table of values, which is always a safe place to start when you don't know what something looks like. So 0 in this exponent, let's forget about the 2 for a second. 0 in this exponent is 1. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the negative 1 is the upside down of 2. 2 to the negative 2 is the upside down of 4. So I'm going to try to put those things on this grid. Except this thing says take all these points and go up 2. So I'm going to do that. So this is not what we're going to do our flipping job with, because those aren't the end result points. So let's start. Good place to start would be putting labels on the x and y axis. Then let's do some nice ones. 0, 1, but I can't leave it there. I have to move it up 2. So I'm going to do that each time. 1, 2, but up 1, 2 from there. 2, 1, 2, 3, 4, but up 2 from there. I'm going to restart. Again, I've said I'm tired. I really mean it. I should not be doing math videos at 9:30 at night. Let's see what happens here. So, as I said, 0, 1 is here, but I have to take it up 1, 2. Let's see if this fits. 1, 2 is here, but I have to take it up 2. 2, 4, then up 2. So it should be there, but I have to go up 2. And then 3, 8, 3, 1, 2, 3, 4, 5, 6, 7, 8, but up 2. Oh, almost blew it again. Negative 1, a half, but up 1, 2. Negative 2, a quarter, but up 2. And probably one of the more important things for this one is you've got your horizontal axis, your horizontal asymptote, which is usually running through there, but now it's going to go up 2. So now your horizontal asymptote isn't y equals 0, it's y equals up 2. And I can do my best job, pressure's on, to connect these dots. Okay, I'm just bad at this. And try not to touch the horizontal asymptote. Okay, I'm going to quit while I'm ahead, right there. So that is f at x is equal to 2 to the x plus 2. So I need to find some of these dots, and because I am sleepy, I'm going to write the dots down here. So I'm going to start here, because it's pretty. So 0 across, 3 up. 1 across, 1, 2, 3, 4 up. 2 across, 1, 2, 3, 4, 5, 6 up. 3 across, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up. Negative 1 across is not a very nice one. So that one was 1, 2, and a half up. And finally, negative 2, although I could probably fake this one, -2, and then 1, 2 1/4 up. And then what I'm going to do is dig out the old blue pen and do my inverse steps. So this one will be 1, 2, 3, 4, 5, 6, 2. So it depends on how awake you are. I am not, so I'm actually listing the points. And you've seen a couple of examples already where I can't even do that properly. I'm going to stop there because I think I can fake this one. So that one was 6, 2, 1, 2, 3, 4, 1, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 3. Didn't do that one either. And 1, 2 1/2, -1. So hopefully you can see that the horizontal asymptote of y equals 2 in the inverse becomes x equals 2. And this should not be a surprise, because if you followed the last note, which was review, part of the step was to literally switch the x's and y's. So what's happened here is I have literally switched the x's and y's. And of course you're confused because somehow my 0 popped out of nowhere. So now I've got something to make my curve head towards. Not that that helps when I'm using this silly technology that doesn't let me touch my screen. See how I do? Hey, that's not bad. And then here I'm heading towards that, and like I said, I can get closer and closer and sort of fake that. And if I turn my head sideways to imagine the line y equals x, this does reflect. I'm doing 45 degrees right ear to right shoulder. And just in case you care how messed up I am, I see a butterfly. Okay, so now that you know how messed up I am, let's do the work for finding these inverse equations. And then we have 2 more graphs, or 1, depending on my hand crampedness. So we started with y equals 3 to the x. And the first step that I showed you here was to literally switch the x's and the y's and then solve for y. So I'm literally turning my y's into x's and my x's into y's, every one of them if there's a multiple amount of them. Now the thing is, if I go back to yesterday's note and I look at, I don't know, a quadratic example, we switched the x's and y's, and then we had to get the y by itself, we had to undo all the math backwards. So we had to take the -3 over, so we know the opposite of subtraction is addition. No biggie. We know that the opposite of multiplication is division. No biggie. We know that the opposite of squaring is plus minus square rooting. We know that the opposite of addition is subtraction. Even when I look at the fraction example, we knew that the opposite of dividing was timesing. The problem is, when you get to a question that uses exponents, is there is no way of getting this y isolated. So what you have to do is follow something that John Napier, a guy from Scotland, made up many, many centuries ago, and that is logarithms. So I'm going to show you the pattern, and then we're going to follow it hopefully numerous times today. So here it is. To get the y all by itself down on the ground, you do this thing called logarithm, in short, log. You need a little number down here, and that little number is dictated by this base, because it's actually called a base. So I'm going to put the 3 there, and the x is there. So basically, this is the undoing of something that you've never been able to undo until this point. And this is your inverse equation, because the y is all by itself. Now, it is very important that this little 3 sits a little bit downstairs. So you can't make it rise up into the air and make it even. So if I'm drawing the lines on the page, which I've got here but didn't really use, all this stuff is on ground level and the 3 just dips down. It's a subscript, as opposed to this, which if you're looking at fonts is a superscript. So the superscripts are exponents, subscripts are bases for logarithms. If I can make this little 3 go downstairs, with this tablet, you can make this little 3 go downstairs. All right, next one. Hopefully you will eventually pick up this pattern. So y is equal to 1/3, and because it's bulky, we set it in a bracket, to the x. Step 1, switch your x's and y's. Step 2, panic. You have no way of getting this y down on the ground. So what do? You dig out logarithms. So you isolate y. You write down a word that you have never seen before. Basically, logarithms are anti-exponents. This is going to be very tough for me. If I can pull this off, you can pull this off. This little base, slightly downstairs, is 1/3, and then the x comes back to ground level. Now the part that truly is terrible for me is I have to do that one more time right here. I can do this way easier with a pencil and paper. There it is, dip down. I'm choosing to make a slashy fraction, x back up on ground level. And just to prove to you that I can do this over and over again, hand cramps and all, this is technically the end. So I should say that's a therefore statement and back it up to this one. I really should have summed this one up with, not that. Therefore, f inverse at x is equal to log base 3 of x. So that's how you say that. And I will write this down at least one more time in the course of the lessons. One we didn't do is this one. So this one's a little bit trickier. So the original was y equals 2 to the x, then plus 2. So with this one, I switch my x's with my y's. And you don't go all logarithm yet. You have to make sure that it's set up to do that properly. So the first step is actually removing this plus 2 and using opposite operations so that your y is as isolated as possible before you pull out logarithms. So now this is a tiny little quantity, way tinier than it was before, and now you can do your magic. So can you remember what to do with it? Isolate the y, logarithm, base 2, because that's a base on the exponent, and then x minus 2. And this is wrong unless you put x minus 2 in a bracket to say that was there already as a bigger quantity. And then just to prove to you that it is not that difficult to make that 2 belong where it's supposed to belong, as in not on the regular line but a subscript, we have that. And now I have to do it again. see if I got that right. Yay! Graph, graph, asymptote, asymptote, label, label. It's all good. Okay, let's do one from scratch. Do you know what's happening to this thing? So this is the exact same graph as this one, only some weird things are happening. Now I am going to steal this information because we still have the base graph is the same, and that is the y equals 2 to the x part of it. Now I'm going to lead you through this one a little bit different because there's no stretch or compression. Instead, there's a flip. So what that means, so bear with me, I'm going to do this in green so you don't think it's anything original. I still see 8, so I'm going to pull this down. And I'm going to pull this over before I put on my y and x-axis labels. So bear with me for a second. Really, this graph is going through 0, 1, as in the original, 1, 2, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, and -1, 1/2, and -2, 1/4. So what happens with this little negative out front is you have to flip over the y-axis. So there's no way I'm connecting those dots. I mean, you've already seen how bad I am at it. So instead, I'm going to take those dots and I'm going to flip them over the y-axis. So this one's going to flip here. This one's going to flip here. This one's going to flip 1, 2, 3, 1, 2, 3 here. This one's going to flip here. This one's going to flip here. And this one is going to stay where it is because you don't flip it. So now I'm going to erase all those green dots. They are meaningless to me now. And if you think you're going to connect those dots, you're wrong. Because in addition to that, we have to worry about this number, which I do not want in red. This number, which says go right, so the opposite of -3, and this number, which says go down 1. So I have the magic smartboard ability to take every single one of these dots, I hope, and move them to the right 3 and down 1. So this one, right, 1, 2, 3, down 1. This one, 1, 2, 3, down 1. Next one, 1, 2, 3, down 1. This one, oh yeah, 1, 2, 3, down 1. And there is an asymptote sitting right here on the x-axis, and if you move this asymptote over to the right 3, it won't mean anything at all because it's going on forever, but at least it has to go down 1. So that means that we have an asymptote for this particular picture, and it's going to be y equals -1. And now I can connect these dots into my smooth curve, or as smooth as I can make it. Wish me luck. Ah! Okay. Oh. This is getting embarrassing. All right. Doesn't matter if you call that y or f at x. What matters is that the next one is f inverse at x. So I have to find these points so that I can do the old flip job here and graph a blue one. So let's leave it there. So remember, these are not the end result points. Those are the ones I started moving around and flipping. I hope, before we start, that you have picked up on the fact that because my original f at x function has a horizontal asymptote at y equals -1, my inverse function will have a vertical asymptote at x equals -1. So now let's find some dots. Remember, we're counting from the origin, not from here or some other random spot. 1, 1, 2, 3. One, two, one. One, two, three, nothing. Should probably do this one. 1, 2, 3, 4, 5, 6, 7. So that's 0, 7. This guy. 1, 2, 3, 4, and then down a half. And the next one will be 5. This is going to be tricky. 1, 2, 3, 4, 5. And then this is the quarter space. So this is a 3/4 space in the negative direction. Not that you couldn't fake that one. I just wanted to impress you with my number knowledge. That is your list of f at x points. And now I'm going to create my list of f inverse. Yell at me if I screw this up. Like that. See, I caught myself this time. I must be getting less sleepy. You wouldn't think that this is the thing I have the most difficulty with. The nice thing is, if you know that reflection business over the line y equals x, if you make a mistake, you can catch yourself. Which often happens to me because for some reason I find it reasonably difficult, obviously, to flip these points around. So let's see me do this job. Counting. 1, 2, 3, 1. 1, 1, 2. 0, 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 0. Negative a half, 1, 2, 3, 4. Hey, this is working out nicely, as it should. And negative 3/4, 5. And then my job is to try to draw those in a straight curve. Sorry, a smooth curve. Nothing straight about this. So you're not heading towards this axis, or sorry, this asymptote. So let's visually get it out of the way for a second. All you're doing is trying to connect the blue dots and use the vertical asymptote. Can you hear me sighing as I do this? And that is f inverse at x equals. Oh, turn my head 45 degrees and awful, but yeah, it works. Before I forget, this guy is supposed to be sitting there. All right, let's find this equation. Not worth it. I thought I could just steal it. Y equals -2 to the exponent x minus 3 minus 1. My only complaint about logarithms is, just like exponents, they might take up more than one line unless you're a tiny printer, which, as you can tell, I am not. Not even on paper am I a tiny printer. Step 1, what is it? Switch your x's and y's. Step 2, decide if you like this as negative. If it's not negative, you might as well keep it, but if it is negative, you are welcome to take it to the other side. And I'm going to put the negative 1 down, and then the negative x from the left-hand side. It doesn't matter the order of these as long as they're both negative. So now we have to do our stuff. So usually this is y equals, because usually what's sitting up here is a y. Now it's a y minus 3 log. Our base was a 2, so down here is a 2, and then this sits after it in a bracket because it's more than one piece of information. And then finally, we're trying to get y all by itself. So I'm going to save myself a line and maybe a hand cramp. So what's there originally, and then I have to pull the 3 over, and it reverses from a subtract 3 to an add 3. And this stuff right here, oh yes, I have the technology, just not the neatness. There. And anybody reading my work shouldn't have a problem with it, because even if it's not labeled as neatly as it could be, it is color coordinated. So you can see that my blue f inverse at x equation goes with the blue curve, and my red equation goes with the red curve. All right, so I'm making a decision with this last question to not graph it, but instead, let's do the equation of the inverse. So can we go through the steps to just finding f inverse at x? Step 1, swap. And I'm a little bit freer right now because I have lots of space. Step 2, decide if this quantity is happily positive, or if you want to switch it, it is happily positive. I am going to leave it behind because I like positive things, especially positive y's. And I realize the y itself is positive, but we want this chunk of information to be positive, which also means I have to take the subtract 5 across the equal sign and add it. Then, what makes this question more difficult is we have this 2 that's kind of in the way. So I have to divide by 2. And how that ends up looking is you still have 3 to the exponent y plus 4, but on the left-hand side you have x plus 5. All of it was there before you divided by 2, so it needs to be written like that. So now you've got base exponent. So you can unexponent using logs. So the exponent comes down, so you've unexponented, not a technical term. Logarithm, base was 3, so this little number down here is a 3, and then this has to sit in a bracket, especially this, because it's a whole bunch of stuff. And then you're sad because you don't have the y by itself, but you have only one more line if you want to be just like me and take out one line. So we're going to have the y all by itself. So we'll be done the inverse, and we'll have log base 3 of x plus 5 over 2 subtract 4. So what we've learned today is, I guess, reviewed how to take care of exponential functions, and we now know what logarithmic functions look like. And we've also gone through the steps to actually find out what logarithms are, that being anti-exponents. Back it up just a little bit to the very beginning, so I guess that's not just a little bit. I want you to know that every single basic log graph before you start moving it around looks like this. So you need to know that every single log graph never hits 0 on the x, and it never goes into the negative. It does when you start transforming it, when you start putting negatives in and start moving things sideways or up and down, then it changes things entirely. But the original log graph does not have, I'm going to put a little note here because it's super important, no, oh, I'm going to start that more in the positive. I don't want to be all negative today. All positive x values. That's it. There's no 0 x value. There's no negative x values. So even though I could say it in the negative, I've decided to keep it all positive. So the homework is not listed here. The suggested questions are not listed here. Instead, they are on the Google site if you are accessing that. I don't know why I'm moving this other than to make it look prettier. So that is it. So the next thing we do is we start talking about logarithm rules, which is how you do things in real life if you go into certain subjects, which I assume there's a chance of you doing so because you are taking the advanced functions class, or you might be using this to review for calculus. So either way, let's see the damage. Okay, I knew it was going to take me that long. That's why we split this up into the review and this one. So that is all gone.